All right, let's dive right in. Today, we are going to use the lens of modern physics to tackle one of the biggest, oldest, most fundamental questions anyone has ever asked. For almost all of human history, this question, why is there something rather than nothing, belonged to philosophers and theologians. It just felt unanswerable, right? But something absolutely remarkable has happened over the last few decades. This ultimate question has jumped from the pages of ancient texts right into the world of modern physics. And the answer that physics is starting to uncover is, well, it's pretty startling. It suggests that our entire existence might just be the result of a completely random event in the void.
So get this. The core idea is that everything we see around us, every star, every galaxy, you, me, all of it could just be the after effect of a tiny, random ripple in a primordial vacuum that got blown up to an unbelievable scale. Our whole universe, just an echo of a single quantum event.
Now, to really wrap your head around this, you kind of have to throw out your everyday idea of what nothing means. Because in physics, the vacuum, empty space, isn't empty at all, not even close. See, we tend to think of a vacuum as just void, empty, silent, stable, and honestly pretty boring. But quantum mechanics, it paints a totally different picture. The quantum vacuum is a seething, roiling sea of energy, a quantum foam where particles are constantly popping into and out of existence. It is anything but boring. And this frantic activity is what we call a quantum fluctuation. You can think of it like this. Thanks to a rule called Heisenberg's uncertainty principle, the vacuum can borrow a little bit of energy to create a pair of particles out of thin air. They exist for just a fraction of a second, and then they annihilate each other, paying the energy back. This isn't a rare event. It's happening literally everywhere, all the time. And I know what you're thinking. Okay, that's a cool theory, but is it real? Oh, it's real. We can actually measure the effects of this restless vacuum. For example, the Casimir effect is where you put two metal plates super close together in a vacuum, and they actually get pushed together by the quantum foam around them. It's a real, measurable force driven by nothing. Okay, so the vacuum is constantly creating these tiny little shutters of existence. But how do you get from a flicker that's smaller than an atom to our entire sprawling universe? Well, you need a cosmic amplifier. And that amplifier has a name: cosmic inflation. The theory is that in the very first moments of time, one of these random quantum fluctuations got caught in a runaway exponential expansion. This period of inflation grabbed that tiny ripple and stretched it to a truly astronomical size. And when I say fast, I mean unimaginably fast. The whole thing was over in less than 10 to the minus 32 seconds. It's a number so small it's basically meaningless. But in that sliver of a moment, the universe just kept doubling and doubling and doubling in size, basically locking in that initial quantum ripple on a massive scale. So the whole process is actually, well, kind of simple when you break it down. Step 1, a random quantum fluctuation just pops into existence. Step 2, inflation grabs hold of it and stretches it to a cosmic scale. And then, step 3, inflation suddenly stops, and all of that incredible expansion energy gets converted into a hot, dense soup of matter and radiation. And that final step, that's what we call the Big Bang. Now, this whole story might sound like something straight out of science fiction, but here's the beautiful part. This theory makes very specific, testable predictions, and the evidence that it's right is quite literally written across the sky for all of us to see. And that description is the perfect way to think about something called the cosmic microwave background, or CMB. The CMB is essentially the afterglow of the Big Bang, the oldest light in the universe. And when we create a map of it, we see it has tiny little hot and cold spots. What we're looking at is basically a baby picture of the universe, a direct photograph of those original quantum ripples, now magnified across the entire cosmos. And these tiny little variations, they were everything. The spots that were just a fraction of a degree warmer were a tiny bit denser. And because they were denser, they had more gravity. So over billions of years, they pulled in more and more matter, becoming the seeds for all the galaxies and galaxy clusters we see today. The colder, less dense spots became the vast, empty voids in between. And here's the kicker. The predictions match what we see with absolutely stunning precision. The exact pattern of those spots in the CMB, the way galaxies are clustered together in a giant cosmic web, and the fact that the universe appears to be geometrically flat, all of these things are perfectly explained by inflation. That flatness, for example, is just what you'd expect if you stretch something so much that any original curve just disappears. Kind of like how the Earth seems flat to us. The evidence is just overwhelming. When you stop and think about it, the implications here are just profound. This isn't just about the cosmos. This is about us. It changes our entire understanding of where we came from. So this brings up a huge puzzle. How can you create a whole universe from nothing without breaking the fundamental laws of physics, like the conservation of energy? Well, the answer might be that the universe is the ultimate balanced book. All the positive energy from matter and radiation seems to be perfectly canceled out by the negative energy of gravity. The grand total energy of our entire universe could be exactly zero. In other words, it's the ultimate free lunch. And if you follow this logic, you end up somewhere even stranger. If the laws of physics allow for one universe to fluctuate into existence from nothing, why would it only happen once? A lot of physicists now think that inflation might be eternal, constantly spawning new bubble universes from the quantum foam, each with its own Big Bang. It suggests we could be part of a vast, maybe infinite, multi-universe. So, what this all comes down to is something both humbling and absolutely awe-inspiring. The largest structures in the cosmos, the existence of our own Milky Way galaxy, even the very atoms that make you, can all be traced back to a single, random, microscopic shutter in the void. And that leaves us with one final thought. What started as this unanswerable philosophical riddle might have an explanation that's almost as mundane as the random static you hear on an old radio. And if our magnificent, complex cosmos is just one channel that happened to come into focus out of that noise, it just makes you wonder, doesn't it? How many other channels are out there, each one playing its own cosmic symphony?